So Unit 4 is about oscillators. So we are going to see what are the conditions for oscillations, how we are going to design the oscillator circuits using BJT, and three broad types of oscillator categories we have: LC, RC, and crystal. So we are going to see how LC oscillators are designed, what is the principle of working of the quartz crystal oscillators, and RC phase shift oscillators, which was asked for a CAT 2. So this RC phase shift alone will be omitted for your CAT 2, so remaining portions will be fully coming for your CAT 3. So as you know, the basics of oscillators are electronic circuits which are going to produce periodic voltages or periodic currents, and they are going to operate only with the DC biasing voltage, whatever you are going to give, and we are not going to externally supply any AC signal to the oscillator. The oscillator is essentially an electronic circuit which generates periodic voltages. That periodic voltage may be any type of waveform, and it is periodic means the waveform is repetitive in nature. You are going to provide only the DC biasing supply to your oscillator, and you are not going to connect any function generator or AC supply to an oscillator. It is going to generate the periodic voltage of its own only with available DC bias voltage. So generate the oscillations, the circuit this energy has to be given, that is given in the form of DC source. So you know, for any BJT circuit, for operating in the Q point, we need the biasing circuit. So mostly in all oscillators, we'll be using voltage divider bias. So that will ensure that the Q point is always in the middle of your DC load line. So if the output voltage is a sine function, it is called as sinusoidal or harmonic oscillators. Or if it is square function, you call it as a square wave oscillator or sawtooth wave. So you have a lot of waveforms which are periodic in nature. So depending on the type of waveform generated, that corresponding name is given to the oscillator. And oscillator works on two principles. One is positive feedback and one is negative resistance. So these are the two mechanisms by which you can generate oscillations in an BJT. Okay, so broadly, if you classify the oscillators, you have sinusoidal and non-sinusoidal. Sinusoidal, you know, it is going to generate sine wave and cos wave. Non-sinusoidal oscillators will generate waveforms such as square wave, rectangular wave, triangular wave, or sawtooth wave. So that is going to be non-sinusoidal oscillator. Square wave means, you know, it has an on time and off time. So this should be a proper square wave. So rectangular wave means the wave will have either a longer off time, very short on time, or it can have a very short off time and a longer on time. So this can be a rectangular waveform. Triangular waveform, you know, it can be a perfect triangle or it can be sawtooth. So sawtooth waveform will look like this. You have periodic triangular right angle triangles. That is going to be sawtooth waveform. So mechanism of oscillation, two ways, positive feedback and negative resistance. Types of oscillators, you have two broad categories: sinusoidal oscillators and non-sinusoidal oscillators. So in this unit, we are going to predominantly see only oscillators which generate sinusoidal oscillations. So non-sinusoidal oscillators, we are not having as a part of this syllabus.